Hi everyone, and this video is the part 2 video which continue from the previous video on the reinforcement practice of the topic 4 function. So now we continue with this question. Sketch the graph of the function f(x) equals to this quadratic function, and the domain for this quadratic function is from -3 to 6. Determine the range of f. So to sketch this function, I would like to change this question the function into its completed square form, which here just copy down the first two terms. So the technique of completing the square, I already done it for so many times in my previous video. You can always check the video. So this is -3 over 2 square. You get -9 over 4 minus 10. Simplified it. You got it x minus 3 over 2 square minus 49 over 4. Okay, so this is our function and is the completing square form, where you can know that the which is a coefficient of this factor, is 1 and greater than 0. So we can say that this function having the minimum point, and the minimum point coordinate is 3 over 2, negative 49 over 4. To sketch the curve, I will just plot the minimum point, where this is a 3 over 2, and the y coordinate is negative 49 over 4. So our minimum point is around here. And now I'm going to sketch the graph with the parabola shape, and we know that it will passes through the x-axis, right? So we can get the root from this for this function by putting the f(x) equals to 0, and we solve it. Okay, when I solve, I got the two roots for this equation, for this function. The roots is at the -2 and the 5. Okay, 5. So it means that the graph will passes through these 3 points. Now we can sketch the graph. All right, this is not yet our y equals to f(x), because for this question, the domain given here is from -3 to 6. Domain of this function is from -3 to 6. So we are going to sketch the graph from -3, -3 roughly here, and up to 6. Okay, this is 6. All right, so we just cut our graph and at these 2 points, and then now I'm going to highlight the graph that I want to remain. Use the dance circle to cut the point. Okay, then the rest we can just erase off. Okay, the excess we can just erase off. So we just have this graph, and now we need to get what is the value of y when x equals to -3 and 6. Now just substitute -3 into your x. Put the -3 into your x. You will have a y equals to 8, and when x equals to 6, what is the value of y? It is equals to 8 as well. Means that at x equals to -3 and at x equals to 6, they are having the same height. That is at the y equals to 8. So we just can label this as 8. Now we can just label this graph as a y equals to f(x), because you already take care of the domain and the shape of the graph and everything. Now the question asks us to find the range. Determine the range of f(x). Look at the graph. The lowest point of the graph is at the -49 over 4. So the domain will be starting from the -49 over 4, including this value. And the highest point is at 8. So we can see the dance circle to show that this graph also included the y equals to 8. So our range will be from -49 over 4 until 8. For this question, just similar question to the previous question. We just need to do completing the square in order to determine is the minimum point, so that I can sketch the graph. Firstly, I will just factor out the 2. Okay, factor out the 2. I got my negative 5 over 2x minus 3 over 2. And then complete the square. We have this. After we have complete the square, we have the fx in this form. And this shows that the a is equals to 2, which is greater than 0. And this graph having the minimum shape, minimum point. Now, the minimum point will be given by 5 over 4, negative 49 over 8. Now you can just sketch the graph, all right? If you want to sketch a graph, you also can get the roots at once, meaning that you let the fx equals to 0. You make the fx equals to 0, solve for the roots first. Okay, so this will be, after you have solved it, you got the first root, x equals to 3, and the second root is x equals to negative 3 over 4. Now we're going to sketch the graph by preparing your Cartesian, plotting the minimum point, that is 5 over 4 and negative 49 over 8. 5 over 4 is maybe around here. Okay, I put this here as 5 over 4. You always can change to the decimal to estimate how big is 5 over 4. And negative 49 over 8 is roughly negative 6 point something. So here will be negative 49 over 8. Okay, so just plot your graph, plot your point. Okay, this is a minimum point, and the two roots will be given as this. One is a negative 3 over 4. You can sketch negative 3 over 4 around here, and x equals to 3 must be symmetry, right? So you must see plotting the symmetry point. The length from the 5 over 4 is almost the same from the length from the 5 over 4 to 3. So your graph will passes through this 3 point. Now you can start to sketch your graph. This is the graph of y equals to fx. Now we can see that there is one important point, that is a y-intercept. You can get the y-intercept by substituting the x equals to 0. Put the x equals to 0. You can see that the y equals to negative 3. So here you can label as a negative 3. Okay, then see what else we need to find. Find the range of the fx. The range of the fx, you will have to look for the domain, of course, is from negative infinity up to infinity. And the range of the f will be finding the lowest point of the graph, that is negative 49 over 8. Okay, seeking for the value of the y of the lowest point of the graph. And the graph is going up indefinitely, meaning that the y value for the end point is can be represented by infinity. So your range will be this one. And the second question asks us to determine the interval of x for which fx is less than 0, meaning that we are going to solve for the inequality involving this quadratic. To solve this function, to solve fx less than 0, I'm going to factorize this first, because what I can see is the root is having a very nice number, so I can be sure that this function can be factorized. Sorry, I have made a mistake over here. Just now when I get the roots for the function, I got it wrong here. Negative 7 over 4 plus 5 over 4, it should be negative 1 over 2. So I will just correct here. That is a negative 1 over 2. This point having the coordinate negative 1 over 2, 0. Okay, continue. I'm going to, so got the 2x, x, and 3, 1. So you have your negative, positive. Expand back, see if you get back this function. You got negative 6x plus 1x, that is negative 5x minus 3. Yeah, it's correct. Then to solve the fx less than 0, we can write this statement, that is 2x plus 1 multiplied by x minus 3 less than 0. Okay, so to solve this, I'm going to look at my graph. Okay, my graph. We want the function which is less than 0, right? We will look at the graph which is the graph which is a lower, okay, between below the x-axis. Okay, we will focus on the graph below the x-axis. Okay, below the x-axis, the graph exists from -1/2 to 3. Okay, from -1/2 to 3, in between -1/2 and 3, you can see the graph below the x-axis. That's why you say that. Okay, from the graph, we know that the graph, okay, having the roots of -1/2 and 3, and now you want this function to be less than 0. We focus on the graph below the x-axis, meaning that the graph exists in between -1/2 and 3. So my answer is x is in between -1/2 and 3, and you always can write your answer in the set form. Okay, or you might give your answer in this form interval, that is a -1/2 and 3. Both we are accept. For this example, is given the f(x) function and the gx function. Question 1 asks us to find f minus gx. Yeah, so f minus gx, meaning that we need to get f(x), taking the f(x) minus gx first. Okay, so we have a 2x plus 1 minus x squared plus 2x minus 1. Simplified it, you will have a negative x squared. 2x minus 2x, you get 0. 1 plus 1, you get 2. So this is your f minus gx. So f minus g will bring your x to the negative x squared plus 2. For the question 2, we need to evaluate 3g minus 2f of 1. So get your 3gx first. 3gx minus 2fx first. So 3gx minus 2fx is 3 multiplied by gx, which the gx is x squared plus 2x minus 1 minus 2fx. The fx is 2x plus 1. Simplify the function. You have a 3x squared plus 6x minus 3 minus 4x minus 2. Simplify further. You have 3x squared plus 2x minus 5. So this is your 3g minus 2f. X is equals to 3x squared plus 2x minus 5. And the question asking for 3g minus 2f of 1. So now you need to put the 1 into the x. That is 3g minus 2f of 1 will be equivalent to 3, 1 squared plus 2 multiplied by 1 minus 5. That will be 3 plus 2 will be 5, 5 minus 5 will be 0. Looking at this example, we have given a third function, square root function. State the domain and the range of the f(x). So we can find the domain by putting this 2x plus 1/2 greater or equals to 0, because inside the square root we always not allow negative number. So try to solve for this inequality. You will have 2x greater or equals to -1/2, and the x is greater or equals to, divide both sides by 2, you get a -1/4. Actually, this is your domain. Okay, your domain will be x greater or equals to -1/4, or you might present your answer in the interval form, that is from -1/4 to infinity. Alright, both we can accept. And to determine the range, we can see that this square root all will be positive. Alright, the minimum point for the y is 0, because when this x is equals to -1/4, you will get the square root of 0. The minimum value is 0, so the range will be from the 0 to infinity. It is always positive because of the square root. Yeah. And now we want to sketch the graph on the same axis. Sketch the graph of f(x). Okay. Now, just get prepared for sketch your Cartesian plane, y-axis and x-axis. Based on the basic function, y equals to square root of x, we know the shape of the graph is like this. Yeah, it goes start from the origin and it go up to the right and go up indefinitely. This is the shape of the y equals to square root of x. If you have a square root of 2x plus 1 over 2, this function also having the same shape as this graph, but now the graph will just shift to the left hand side because our domain is starting from the negative 1 over 4, meaning that your starting point here, that is origin, now shifted to negative 1 over 4 unit to the left hand side, and the shape of the graph still remain unchanged. Then you can see that there is one important point you need to find it out, that is putting your x equals to 0. Putting your x equals to 0, your y will be sort of 1 over 2. So this value is actually sort of 1 over 2. And now you can label this as a y equals to fx. For this example, you have given g-axis as a square root of x minus 2, and the domain already given over here. Even the domain is not given, you must know that x is greater or equals to 2 by putting the x minus 2. X minus 2 always has to be greater or equals to 0. From here, you solve it, you got the x greater or equals to 2. Okay, then we need to show that the graph gx is a one-to-one function. You can either use a graphical method or algebraic method. So here in this question, I'll try to use algebraic method. To use the algebraic method, we need to define x1 and x2. Be the x1 and x2, let the x1 and x2 be the domain of the function. And I would say that start from this equation. Since this question using the symbol g, so I would just use gx1 equals to gx2. What does it mean by the gx1? Meaning that we are going to substitute x1 into the function. That is, you got the square root of x1 minus 2. And the gx2 means that you substitute x2 into the x here, produce a square root of x2 minus 2. Then square both sides, you will have x1 minus 2 equals to x2 minus 2. Okay, add 2 at both sides, you will obtain x1 equals to x2. This means that x1 equals to x2 means you only got one value of x, bringing to one value of y. So we can say that since g, I'm going to use gx1 equals to gx2 implies to x1 equals to x2. Therefore, we say that g is one-to-one function. Alright, then we have answered the question A. Question B, find the G inverse. If you say that G is a one-to-one function, means that definitely the G inverse is exists. Okay, again, I copy down the question. The fx is square root of x minus 2. Okay, sorry. Again, gx, sorry. Now, to get the inverse, I'm going to start from this statement. G inverse equals to x. And put G inverse into the bracket, then you can see obviously that what does it mean by the G inverse? G inverse meaning that you are putting the x here as the G inverse. The same thing happened to this x. Okay, so G inverse can be written as square root of G inverse minus 2, and this is equals to the x. Just copy down. To get the G inverse, I'm going to square both sides. Then I got my x squared. Alright, and the G inverse is equals to x squared plus 2. For this question, I'm going to show f is a one-to-one function by using graphical method. Okay, for previous question, I use a algebraic method. Here, I'm going to show you graphical method. When I talk about graphical method, you know that there exists graph. Okay, so we try to sketch the graph of the fx first. before we sketch the graph, I would try to find its domain by putting the 3 minus 2 as greater or equals to 0 and solve it. You will have x less than or equals to 3 over 2. This means that your graph will having the shape same as the y equals to square root of x. We know that y equals to square root of x. The shape of the graph is like this. Must always remember the shape first. This is a y equals to square root of x. Alright, then I predict that they're having the same shape because it's a similar function. Only what is the difference between them is now the starting point here. Originally we have the graph starting from the square origin. Now this point as my reference point will be will be at the 3 over 2. And you can see that the the coefficient of the x now is become negative. Okay, for this one, our basic graph, the coefficient is 1, positive for the x. But here I got negative. Okay, since you have a square root of negative x, I can tell you that square root of negative x is like this, the graph. It's as if that it will be reflected about the y-axis. This is a y equals to square root of negative x. So the shape of the graph will be, for our function, will be similar to the square root of negative x since the coefficient of x is negative. So now we can know that the graph will be in this way, in this shape, but now it will shifted 3 over 2 units to the right side. Okay, so as if that this is just 3 over 2. The graph, the starting point here, okay, this reference point will located at the 3 over 2, and the shape will follow the shape of the square root of negative x. It will be like this. Okay, so this is your y-axis. Don't forget to label. And now you can see that the graph passing through a y-intercept. Okay, y-axis at this point. Just get this point by putting the x equals to 0. You get this point as a set 3. So the graph already completed. You want to show that f is a one-to-one function, right? You can always use the graphical method. That is your horizontal line test. Graphical method, also known as a horizontal line test for this case. Meaning that we are going to sketch horizontal line. I use a green color to sketch a horizontal line on my graph. Okay, my horizontal line always passes through my graph at only one point. No matter how many horizontal line you sketch, you can always see that horizontal line passes through your graph at only one point. So we need to make conclusion. The horizontal line, the first sentence is my reason, and the second sentence is the conclusion. So the reason we say that each of the horizontal line passes through the curve y equals to fx at only one point. Therefore, f is one-to-one function. So this means that you are using the graphical method to test the function whether it is one-to-one or not one-to-one, or we say many-to-one. Then question B, find the domain and the range of f. The domain, we already found it. The domain just now we already got it. This is our domain. Okay, so for the question B, just answer the question. The domain of f is negative infinity up to 3 over 2, including the 3 over 2. And the range, from the graph we can see that the range is from 0 to infinity. The lowest point is starting from 0 for the value of the y. The lowest point having the y coordinate 0, and then the graph is just going up non-stop, so the range will be 0 to infinity. We have done the B. Now C, determine the inverse function of f. To get the inverse function, again I'm going to start from this statement. Alright, f inverse is equals to x. So what does it mean by the f inverse? Meaning that your x here will be replaced by f inverse. The same thing over this x. So your f inverse will become square root of 3 minus 2 f inverse. This is equals to x. To get the f inverse, I'm going to square both sides. and you got it x squared. Negative 2f inverse is equals to x squared minus 3. Then your f inverse will be equals to 3 minus x squared over 2. For the question D, we are going to sketch the graph. The graph already been sketched. You can now copy one more time at this column. Yeah, I just copy the graph from the part A. This is a graph of y equals to fx. For this example, we're going to find the inverse function of the quadratic function. So to find the quadratic inverse function, I'm going to start from this equation, that is f inverse equals to x. Putting the f inverse in the bracket, we can see clearly that f inverse is actually finding this, putting the f inverse into the x here. So now I can just replace this x by the f inverse. And we have to square it because this x is replaced by f inverse. And plus 1 over 5 equals to x. Then after that, to get the f inverse, I'm going to bring the 5 over, so we got the 5x, and the 1 over to get negative 1. Okay, so here you got square, right? Now, to get the f inverse, I'm going to take the positive negative square root of 5x minus 1. So here we have two functions. One is a positive square root of 5x minus 1. Okay, and the second function is negative square root of 5x minus 1. And now we're wondering to choose which of the function to be our f inverse. We have to consider the domain that is given. All right. Before this, I got the video shows that how to find the inverse for the quadratic function. We are going to consider the domain of the f, because the domain of the f is equivalent to the range of the f inverse. And the domain of the f given here is 0 to infinity, meaning that to choose which of the function to be our f inverse, I'm going to consider the range of the f inverse, which is 0 to infinity, and which of the function will produce 0 to infinity. Let's consider the first function. Square root of 5x minus 1 is always producing positive number because of the square root here and having the positive sign. And if you have a negative sign for the square root, it is always producing negative number. So since the range of the f inverse given here, we know that is from 0 to infinity, meaning that we are going to choose the first function, which I will make my conclusion. F inverse will be equals to positive 5x minus 1. For this question, we're going to find the f of the g inverse negative 7 over 2. So firstly, I'm going to find the g inverse first. To get the g inverse, I'm going to start from this statement, which I will put a bracket for the g inverse. Here we can see that g inverse is actually putting the g inverse to be the x. All right, for this x also the same, substitute the g inverse inside. So now I got my g inverse as the g inverse divided by 2 minus 1. This is equals to x. And now we're trying to make the g inverse as the subject. We're bringing the negative 1 over, we got x plus 1. And bringing the 2 over, we got multiplied by 2. So the g inverse will be 2 of the 2 multiplied by x plus 1. All right. After we get the g inverse, I'm going to get the g inverse of negative 7 over 2. So just find the g inverse of negative 7 over 2. Means that we put the x as a negative 7 over 2 plus 1. What we have here is, I got it, negative 5. Yeah? All right. Once you get this, now the question asking for f of the g inverse negative 7 over 2. We already got it that the g inverse of negative 7 over 2 is equivalent to negative 5. So f of g inverse negative 7 over 2 will be equivalent to f of negative 5, because this the g of negative 7 over 2, we already got it. And now to get the f negative 5, I'm going to put the negative 5 into the x. Alright, so I got my square root of 1 minus 3 multiplied by negative. And now we simplified it. We have 1 plus 15, that will be 16. Square root of 16, that will be equals to 4. So this is the end of my video for this part 2 video, and thank you for watching.